In this video, I will solve a quadratic application question that I call the time temperature problem. This question says that a patient has an illness that typically lasts about 24 hours. The temperature, which is represented by capital T in degrees Fahrenheit of the patient with the lowercase t hours after the illness begins, is given by the following equation. Capital T of lowercase t is equal to negative 0.025 t squared plus 0.62 t plus 98.5. We have to find out when does the patient's temperature reach its maximum value and what is the patient's maximum temperature during the illness. Because I know this is a quadratic equation and it's asking for maximum, that is my key word to let me know that I'm going to be solving for the vertex. Since I'm solving for the vertex, I need to first find the axis of symmetry, and then I can use the axis of symmetry to solve for y. So let me just rewrite this equation to show that t of t is equal to y, and I'm going to change my t's to x's. So this equation becomes y is equal to negative 0.025 x squared plus 0.62 x plus 98.5. Now I can solve for my axis of symmetry. Remember, our axis of symmetry is x is equal to negative b over 2a. So to solve for x, I'm going to say negative 0.62 divided by 2 times negative 0.025. This becomes negative 0.62 divided by negative 0.05, which becomes 12.4. And remember that we were solving for x, which was also the lowercase t, which represented time. So this is going to be hours. So our x is 12.4 hours. Now that we have x, we need to substitute that back into the original equation and solve for y, which was maximum temperature. So the equation becomes y is equal to negative 0.025 times 12.4 squared plus 0.62 times 12.4 plus 98.5. This simplifies to y is equal to negative 3.844 plus 7.688 plus 98.5. And if we add those terms together, we get y is equal to 102.3, which was our maximum temperature. So our units is going to be degrees Fahrenheit. So our maximum temperature is 102.3 degrees Fahrenheit.